Fraction basics.
We see numbers expressed as fractions every day. For instance, the size of this wrench is 9/16 of an inch.
Fractions represent a quantity as measured by some specific whole. For instance, 2/3 of a pizza is a fraction where the whole is one pizza. Fractions consist of a numerator and denominator. The denominator lives on the bottom and tells you how many equal pieces to divide the whole into. The numerator is the number on top. It tells how many of these equal pieces we are referring to.
Pizza! Yes, we love pizza here. The pizza represents a whole pizza. It can be expressed as 1/1 because until you cut out a part, it is one whole piece of one whole pizza.
Now cut it in half and remove the half slice. Now you are left with one of two slices, or half of the whole pizza.
New pizza, veggie. Cut this pizza into 6 even slices and now you have 6/6. Take away 2 slices and you have 4 of 6, or 4 of 6 remaining.
Mixed numbers and improper fractions.
Sometimes the total number of fractional pieces is greater than the whole as defined by the denominator. We can also write these as improper fractions or mixed fractions. For instance, using a ruler scaled in the eighths, we measure a nail that is 9/8. 9/8 is called an improper fraction because the 9 is larger than 8. But there's nothing bad about it. It's a perfectly fine name for this fraction value.
Since we are measuring 1 inch in eighths, the total number of 9/8 exceed the whole. We could also look at this 1 inch and 1/8 of an inch. So we write this with the 1 whole unit expressed as a normal sized number outside and to the left of the 1/8 fraction, so the nail measured 1 1/8 of an inch long. This is called a mixed number. Whether you write a fraction as an improper fraction or a mixed number, it still has the same value, only the name changes.
Some fractions use different sets of numbers to express the same value. This ruler measures in units of inches and fractions of inches. It can measure eighths, quarter, and half-inch parts of 1 inch. Let's start with the eighth of 1 inch scale.
Measuring the nail, we see that it is 4/8. Adjusting to the quarter-inch scale, we see that it is 2/4. Fourths are also known as quarters, so we can also say 2/4. And finally, the half scale measures 1/2 of an inch.
All three fractions represent the same amount. They are called equivalent fractions. But 2/4 is not the smallest form of the fraction. If the numerator and the denominator share common factors, the fraction can be reduced.
Common factors and reducing fractions.
As we know, common factors are the different numbers that can be multiplied together to make the same number. We can find out if common factors exist by factoring the numerator, then the denominator, and comparing the results.
Looking at the face of a clock, we see that it can be broken up into 12 one-hour segments with the hour hand and 12 5-minute segments with the minute hand. Why can we call 6/12 a half hour? Let's reduce it and see.
To reduce 6/12, we first factor the numerator. We see that the factors of 6 are 1 times 6, 3 times 2, and 2 times 3.
Since 3 times 2 and 2 times 3 use the same factors, we'll only include them once.
So the factors of 6 are 1, 2, 3, and 6.
When we factor the denominator, we get 1 times 12, 2 times 6, and 3 times 4. Now that we see there are common factors, we need to reduce 6/12 by dividing both the numerator and the denominator by the largest common factor.
We see that 6 is a good choice because we can reduce the numerator to 1 by dividing 6 into 6. Dividing the denominator by 6, we get 2. Dividing them by 6 equals 1/2. That's why we call it a half hour.
The value of the fraction hasn't changed. It's just been reduced. It remains the same value because the numerator and the denominator have been reduced by the same number, 6. The scale of the denominator is changed by a factor of 6. If we take 6/12 and multiply it by 3/3, the answer, 1836, also reduces to 1/2, and that we have really multiplied 6/12 by 1 in the form of 3/3.
Earlier we learned that when two fractions have the same value, they are equivalent. Equivalent fractions represent the same part of a whole.
Take this square. Until we divide it, the square represents one whole. When we cut it in half and shade it in, the shaded portion equals 1/2.
When we divide it into fourths, we see that the shaded area, 2/4, still represents half of the whole.
When the portion is greater than the whole, the fraction can be written as a mixed number in the following way. 7/4 can be written as 4/4 plus 3/4. The 4/4 is equal to 1, and 3/4 cannot be reduced, so the answer is 1 3/4.
So you see, fractions may be written differently and still remain the same. When comparing fractions, it's important to try to organize the information in a way that allows you to see the difference.
We are given two fractions and asked which is greater, 2/3 or 3/4.
One way to solve this inequality is to build a model. Take a piece of cardstock and fold it in half. Now cut it down the middle. Take one of the pieces of stock and fold it into equal thirds, folding it like a letter. The neater it is, the more accurate it will be. The folds separate the paper into thirds. Now cut it at 2/3.
Fold the second piece in half lengthwise and then fold it in half again. Open it up and there should be 4 equal folds. Cut it at 3/4.
Now place them side by side, and we can see that 3/4 is greater than 2/3.
Converting fractions to decimals. Guess what? We can convert fractions into decimals.
Here we have 10 dimes. 2 dimes is 2 of 10 or 2/10. We can write this as a decimal because we know that the tenths column counts tenths. So a 2 in the tenths column is equal to 2/10.
We know a quarter is equal to 25 cents. 25 cents is also 1/4 of a dollar. 1/4 of a dollar can be expressed as 25 over 100 or 25 hundredths.
25 hundredths is 20 tenths and 5 hundredths. A quarter is 25 hundredths of a dollar.
Adding decimals in the form of money is a common occurrence. 1/4 plus 1/4 equals a $1/2.
Common denominators.
When the numbers are written as fractions, we usually use common denominators to add or subtract. We may be able to conclude that 1/2 plus 1/4 is 3/4 based on experience. But we can use common denominators to add the two fractions together.
2/8 plus 3/4 can be added by finding the lowest common denominator. Two fractions have a common denominator when they have the same denominator. It turns out that the lowest common denominator possible is exactly the least common multiple.
For 2/8 plus 3/4, we look to the denominators and find the multiples of each denominator. Multiples of a number are that number times 1, 2, 3, 4, etc., and every other whole number. You can find the smallest common multiple by hand by listing the multiples of each denominator until you find the first common one.
For the 8, let's list the multiples. 8 times 1 is 8. 2 times 4 is 8.
Moving to the 4, let's list the multiples. 2 times 2 is 4. So is 4 times 1. We can stop because we found a match. The least common multiple is 4.
Now we solve for the lowest common denominator.
4 goes into 8 2 times. 2 goes into 2 1 time. We can now add the two fractions by writing them side by side and add the numerators. We do not add the denominators. The answer will be in fourths.
So we add 1/4 and 3/4 to get 4/4, which is 1.
When working with fractions, one thing will become clear. As the denominators in the fractions get bigger, the parts making up the whole get smaller.
1/2, 2/4, 3/6, 4/8, and 6/12 are all equivalent fractions. As the denominator increases, the whole is separated into smaller parts.
How would we go about trying to make models that represent parts in the thousandths?
Let's think about visualizing thousandths. We could try to use a number line.
We could lay out 1,000 blocks in a row and count and compare that way, but the number line becomes long and awkward to work with.
Instead, let's add a second and third axis. Instead of being limited to the dimensions like length and width, we can now add a third axis that represents height.
Let's consider a cube that is 1 unit by 1 unit. Let this be our whole. Let's divide it into 10 pieces along each axis. That gives 10 pieces, then 100, then 1000. These pieces are all equal, so this block represents one part of 1000 or 1000th.
10 blocks is 10 of 1000, or 10 1000ths. 10 into 10 is 1, and 10 into 1000 is 100, so we have reduced 10 thousandths to 1/100th. Now we have 100 blocks, and 100 of 1000 is the same as 100 thousandths. We reduce by a factor of 10 again, and see that the blocks are 1/10 of 100. 10 times 100 is 1000.
So the total number of blocks is now 1000, with each block representing 1,000th of a unit.
If we take away this many blocks, what number of blocks remains expressed in the thousandths?
Looking closely at our model, we can see that there are two sections that are 5 units deep and 10 units across in this part of the missing section. This is equal to 100. Then we count the 3 remaining missing blocks, and we have a total of 103 blocks missing.
The missing portion expressed in the thousandths is 103 thousandths, and its decimal equivalent is 103 thousandths.
So that's what thousands look like in a model made of square blocks.
It helps to have a model or an equivalent to work with. Numbers don't always come in equal units, so it helps to be creative when problem solving. The situation the number is used in usually dictates which form the number is in.
Well, that's about all the time we have for today. I think we've done pretty well in working with our fractions.